Good afternoon, everybody. Thank you for joining us today. We are doing our webinar on our wireless access points today. So this is kind of an overview of our access points for you. Um, I know we've got a lot of different models out there. So we'll be going through the different models, but we also want to be talking about some of the different technologies that you will find on our access point you may not be familiar with. So this is sort of a general overview of all of our wireless access point products. As we go through today, feel free to ask questions. To do that, use the question and answer interface in Zoom. I can see that as we go through today. I cannot see hands being raised. I cannot see the chat easily. So again, questions, send them in using the question and answer interface. So we'll go ahead and get started talking about our wireless products. To help sort of simplify things, we've sort of combined them together into two different categories: the flexible series of products and the ultimate series of products. The flexible series of products can be managed directly through a web GUI or can be managed with the free Nebula cloud. So this is going to be all of our access points that fall under the 1 and 2 series. So that would be things like the NWA 1123 ACV3, the NWA 210AX, etc. And then on the other side of things, we have our ultimate series. So with these products here, you can manage them directly through a built-in web GUI. You can manage them through our free Nebula cloud. These can also be managed by a local area controller. So you can use a dedicated NXC wireless LAN controller or use one of our Zyxel security products. Almost all of those models have a built-in wireless LAN controller you can use, and those will work with our Ultimate Series APs. These APs are the ones that start with the numbers 5 and 6. So this would be things like the NWA 5123 ACHD or the WAC 650S. These products also include 1 year of Nebula Pro Pack bundled with them. Pro Pack is an add-on to our free Nebula Cloud that unlocks some more features, primarily aimed at MSP users. Also, these APs are much more likely to have some of our advanced wireless technology built in on them, things like a monitoring radio, smart antenna, and we'll talk more about those as we go through today. So one thing I did want to talk about here is how, or I guess what I'd call it, our design philosophy. If you have gone to one of our trade shows in the past, we may have had a demo of this. We will oftentimes have one of our APs. We will have a Ruckus AP. We will have a Ubiquiti AP, and we'll simply have you pick them up and hold them. And you will notice our APs weigh a lot more. And then at least we used to before this demo units got beat up, we would open them up and let you take a look at what was inside, so you could see what was causing that heat difference, or excuse me, the weight difference. So I just want to go through here. What I'm talking about here is going to be true on all of our access points, from our cheap $99 NWA 1123 all the way up to our $600 WAC 650S. They all use the same design philosophy. So when we're dealing with access points, there is solid state technology. So why is it some of them out there will fail after a year or two and others will last a really long time? That's one of the reasons why we can offer a lifetime warranty on our cheap $99 access points. And one of the major causes of failure is heat fatigue. Basically, heat builds up inside the unit. It can cause the switches inside the microprocessors to fail. It can cause solder joints to fail and crack. So the way we've dealt with that is, one thing you'll notice is all of our access points enclosures have a lot of vent holes in them to allow heat out, but they will also have a metal plate behind the PCBA that basically acts as a heat sink, drawing heat off the board and the chips on the board and help venting it out those holes. Another common cause of failure on solid state devices is capacitor failure. So we only use solid state capacitors. We do not use electrolytic capacitors, which can dry out, boil over, burn up. So again, it's true on all of our models of access points. Other things you will see is you will see a lot more shielding on our PCBA. It's generally normal when you open up an access point to see a little shielding specifically around the Wi-Fi chip. You will see a lot more shielding on our board. It's designed not only to help with EMI issues, but also blocks out 4G and 5G. So you may not be aware of this, but there are 4G and 5G service providers out there operating on bands near the open Wi-Fi bands, and there can be overlap and interference, particularly if you're very close to one of their base stations, or if you are in a building which has extenders which amplify and relay the signal throughout the building. So that helps block out and reduce interference from those. Another thing you will see is, unlike most of our competition, we do not mount the antennas directly onto the PCBA. In some cases, in some of our cheaper competition, they just print the antennas directly onto the same PCBA that has everything else. So we will have those antennas lifted up, and on most models, we will also have an anti-noise spreader device, just another piece of metal there that's designed to block EMI coming up from the board to the antenna. So we've got much better isolation on these antennas by having them on their own board and having this shield behind it. So that helps you get a little bit better signal to noise ratio. It doesn't make a big difference when we're talking about a good, strong signal, but for those edge cases where you've got people right on the border, and they're, very common at hotels and other hospitality, where you've got somebody with a phone trying to connect to Wi-Fi and trying to get the signal through a couple walls to the access point. This little extra isolation, this little bit better signal to noise ratio, is a difference between a working and a non-working connection for those edge cases. So one of the technologies that you will see on us that I don't believe anyone else currently offers is dual optimized antenna. So traditionally, with an access point, they're designed to be mounted on the ceiling directly above the area to be covered, and the RF coverage area radiates out in roughly a circular pattern. You'll often see this referred to as umbrella coverage. The problem is, out there in the real world, you don't always get to mount your antennas on the ceiling. Oftentimes, you have to settle for mounting them up on a wall. So when you do that with a ceiling mount antenna, you end up in a situation where you end up shooting a lot of your signal up into the ceiling and down into the floor. You don't get the horizontal coverage that you would maybe want to get. So the way we've dealt with that is we have this dual optimized antenna system where we have two different sets of antennas inside the access point, one that's optimized for your traditional ceiling installation, but then a second set that is designed for wall mount. And it gives you the ability to go in and choose whether you're using ceiling or wall mounting and switch that coverage pattern to be better optimized for those wall mount situations. Another technology that we have is smart antenna technology. Um, our smart antenna technology is very similar to Ruckus. So if you are familiar with Ruckus and their smart antennas, ours is a very similar system. And us two are pretty much the only guys out there really pushing this. So I want to talk a little bit about some of the benefits of smart antenna. And I want to start, though, by talking about co-channel interference. So something a lot of people aren't necessarily aware of is when it comes to radio frequencies that we can use on our wireless access points, the FCC limits us to some very narrow bands. In the 2.4 gigahertz spectrum, we're limited to roughly 60 megahertz of available spectrum that has to be shared amongst all devices operating on 2.4 in the area. The smallest Wi-Fi channel is 22 megahertz in size. So what happens is you only end up with 3 non-overlapping channels. So what happens when you have more than 3 access points? You start getting this what's called co-channel interference, where devices on multiple APs using the same channel try to broadcast at the same time, and it causes packets to drop in really poor performance. So one of the challenges we have is, starting with 11N and everything since then, part of the way to get to that speed you see advertised for those devices is they have doubled the bandwidth to using 40 megahertz channels. So again, we've only got 60 megahertz available here, and you're using 40 of it for a single device. So in this situation, if you are using a 2.4 device or a wireless access point at full speed, you are using a 40 megahertz channel. So as soon as you add a second access point into the area, you will have interference if you're using these 40 megahertz channels. So you've got to reduce them back down to 20, and then you get 3 that you get to use, but you're having your maximum theoretical speed. 5 gigahertz is a lot better for us. As you can see here, we've got well over 20 channels that can be used, 20 megahertz channels that can be used when it comes to Wi-Fi. But again, what I was talking about earlier is the way we get these faster speeds you see advertised is we don't use those 20 megahertz channels. We use wider channels. So if you're using 40 megahertz channels, you see it's a big reduction. The faster 11AC Wave 2 products and 11AX products, Wi-Fi 5 and Wi-Fi 6, are using up to 160 megahertz channels to get those speeds you see advertised. And as you can see, there's only 2 available non-overlapping channels. So again, if you start adding more APs, you're either going to have to deal with interference or you're going to have to reduce the bandwidth being used to be able to fit more in. So one thing I want to draw your attention to here is a lot of these channels fall under this thing here called DFS channels. So what happened is originally Wi-Fi was allowed here on Uni 1 and Uni 3. Uni 2 was already in use by other things such as weather radars, airport radars, and some other technologies that are out there. So when the FCC decided to open this up for Wi-Fi, they had to make accommodations for the fact that there were already people using this space. So they created something called DFS. So DFS basically says if you're going to use these channels, before you can start broadcasting, you have to stop and listen to the channel and make sure there are no legacy devices using that channel. Only once you've done that can you start broadcasting and using that channel. But while it's going on, if you detect another one of these legacy devices, you must stop using that channel. So it causes sometimes some random, a lot of times people don't like to use these channels. One reason being that you never know when you're going to be disconnected. And when it switches to another channel, if it's another DFS channel, before it can start using that channel, there's going to be a bit of a pause while it evaluates if that channel is also being in use. So it can cause people to get dropped and stay offline for a good chunk of time. So oftentimes that's not desirable for the situation you are providing. Another problem you run into, and especially in environments where people bring their own devices, is a lot of consumer equipment doesn't support DFS. So somebody's tablet or phone may not support DFS, so they won't be able to connect to your network. We run into this a lot. We'll have customers call us up, our tech support, and say, hey, we've deployed your networks, but your product isn't compatible with Bob's whatever laptop down in accounting. What's going on here? And we'll check and see they're using a DFS channel, and Bob's laptop doesn't support DFS channels. So because of that, a lot of people don't use these channels. And as you can see, it's a big chunk of your space that you can use. So if you're not using DFS channels, you suddenly lose how many non-overlapping channels you can have. If you're just using 40 megahertz channels, you're down to just 4 non-overlapping channels. If you're using 80 megahertz channel width, you're down to just 2 non-overlapping things. So basically what happens with Wi-Fi is when 2 or more devices try to broadcast at the same time, it causes interference. They each have to take turns broadcasting. So only one device broadcasts at a time. Wi-Fi 6 sort of solves this with upstream MIMO. But with that exception of some of the newer Wi-Fi 6 devices, everything else has to take turns one at a time broadcasting. So again, what happens is when 2 or more devices broadcast at the same time, it generates interference, packets get dropped, you get a bad network connection. So traditionally, the way of doing this is you would spend a lot of time making a sitemap and trying to figure out how you can place your APs while minimizing the overlap on the channels. And you end up reducing the power of the access points. The downside of that is it does help reduce co-channel interference, but it does not, but at the same time, it is going to lower your signal to noise ratio. So you're trading one performance degradation for another type. So one of the cool things about our smart antenna implementation is we've specifically designed it to reduce this co-channel interference. In addition to that, it helps boost coverage area by being able to focus the signal at where client devices are, and it allows you to have more devices on one AP before you start running into interference issues, and more APs in the same general area before you start running into interference issues. So there's just a quick example here. In this case, the source of RF interference isn't another access point, it is a microwave. Microwaves cook using the same 2.4 gigahertz frequency that wireless access points use. So your network's working great. Somebody in the break room turns on the microwave, and now you start having performance issues on your network with a traditional antenna. With smart antenna, we are able to solve that because what smart antenna does is it allows the access point to put together hundreds of different antenna combinations and switch between those antenna configurations based on the current RF environment. So as you can see here, we can go through different antenna patterns and choose an antenna pattern that both directs the signal towards the client device, but also ignores, and my animation isn't working here correctly, ignores where the sources of other interference are. And the nice thing about smart antenna is it's a AP technology. It doesn't require anything special on the client device. And unlike beamforming, it works really well with devices that are in motion. They don't have to be stationary, which is something that's required with beamforming to really truly work. So it's a really good technology out there for those of you that have a lot of users in a small area or have a lot of access points in an area where the RF signal spreads, such as expo centers and conference rooms and things like that. So we did some testing in-house here just to show you. This is comparing our WAC 650S with HP's Aruba AP515. They are both 4x4, 5 gigahertz Wi-Fi 6 devices. And as you will see here, pretty significant difference in performance that you would get in the real world. And we've got other tests we can send you comparing us to other different vendors' devices. But obviously, and any manufacturer is going to tell you theirs is the best. So I've got a third party here I can point you to. This is the University of Brescia in Italy. Their networking group saw claims made by us and Ruckus and decided to test them. So we've got a link there up on the screen. You can go to that link and download the entire testing that they did, all their methodology and all of their results. You can also simply Google Zyxel co-channel interference or Zyxel smart antenna, and it should pull up a white paper that you can give to your customers, which summarizes the key points of the testing they did. But to summarize here, their testing found that co-channel interference issues, smart antenna APs perform up to 70% better than non-smart antenna APs. So they compared us, they compared Ruckus, they compared Cisco, and they compared Aruba. As you can see here, we did 56% better than Cisco, and we even outperformed Ruckus up to 45% in these real-world environments where you are going to have sources of interference. So that's it for smart antenna. We'll spend a few minutes here talking about Wi-Fi 6 because Wi-Fi 6 is still a fairly new technology. On the AP and router side of things, it's easily available. You're still finding on the client side that there's not that much support for Wi-Fi 6, and those devices that claim Wi-Fi 6, a lot of them are what I'm going to call Wi-Fi 6 Lite. They don't support all of the Wi-Fi 6 features necessarily. So Wi-Fi 6 is a new standard for Wi-Fi that was specifically designed to combat some of the big issues that have been facing Wi-Fi since the early days in the late 90s when it was originally ratified and rolled out. So in theory, Wi-Fi 6 devices can be made that support speeds all the way up to 10 gigs. We do not currently offer those. It's specifically designed, though, to handle more users simultaneously and also to deal with some of those issues of having a lot of APs in the same area, similar to smart antenna. The way they deal with it is different than how smart antenna deals with it. So you can combine those two together and get a really great performance boost by combining Wi-Fi 6 tech with smart antenna tech. And Wi-Fi 6 is the first new Wi-Fi technology since 11N that works on the 2.4 gigahertz radio. So that's really cool because 2.4 has been stuck at basically 11N technology all this time. So now with a Wi-Fi 6 device, you're getting those improvements with 11AC, and now these new improvements with Wi-Fi 6 on that 2.4 radio, as well as the 5 radio, and now also a 6 gigahertz radio with Wi-Fi 6E. So some of the new cooler technologies here. Prior to this, 11AC was using what's called OFDM. It basically segmented the airtime into these little chunks of 20 megahertz. With Wi-Fi 6, we get OFDMA. It now allows us to segment up the available Wi-Fi spectrum into much smaller chunks, so you can more properly distribute the frequency or the spectrum being used. So more devices can broadcast at the same time, and those devices that need more spectrum can get more spectrum. Those devices that don't need more spectrum will free up additional spectrum for other devices. We have something new called BSS coloring, which helps identify which packets or which device the packets are intended for, to make it easier for Wi-Fi 6 devices to ignore competing signals from nearby devices. There's a bunch of other new technology in here. One of the coolest things here is just the much better utilization of available airtime. So what happens with 11AC and anything before that is, as you add clients, more and more clients to the access point, the maximum aggregated throughput through that access point actually drops. And the reason it drops is because before Wi-Fi 6, airtime wasn't handled that way. As I mentioned before, we've now got OFDMA. We now have, with Wi-Fi 6, both upstream and downstream MIMO. So you can have multiple clients using different chunks of spectrum talking back to the access point, which wasn't available on 11AC. Wi-Fi 6 also allows the AP to essentially schedule which devices are going to broadcast when. So the overall answer here is, because of all of this, you get much more efficient usage of the theoretical available airtime. And because of that, as you add more and more clients to a Wi-Fi 6 access point, the aggregated throughput remains flat, whereas with 11AC, it drops off. Similar story whether we're talking 1 AP or 2 APs. So I want to talk a little bit here about Wi-Fi 6. When you're out there looking at Wi-Fi 6 products, not all products are going to support the full Wi-Fi 6 feature set. There's two reasons why this happens. One of them is because the devices are using older chips. A lot of vendors rush to market with products marketed as Wi-Fi 6 that were using chips that the chips just don't support all of the features. They weren't available yet. This was very similar to when 11N rolled out. Remember, we had 11N, we had pre-N products. With 11AC, we had 11AC, and then they rolled out Wave 2, 11AC Wave 2, which added new features, not because of the spec, but because the chips weren't ready. And it's the same thing with Wi-Fi 6. And at least at the moment, no one is marketing these products that don't support the full Wi-Fi 6 chipset as something like Wi-Fi 6 Lite, or calling the full Wi-Fi 6 products Wave 2. So it can be confusing when you're looking at Wi-Fi 6 products, because you may not know whether or not they have the full Wi-Fi 6 features. Another common reason why they won't have all the features is for cost savings. So instead, not only are these chips missing some of these features older, but you may also run into situations such as Ubiquiti, where they're only putting Wi-Fi 6 on the 5 gigahertz chip, and they're still using a cheaper, slower 11N chip for the 2.4 radio. So this is just an example. I've got Qualcomm showing the differences in features between the Gen 1 and Gen 2 chips. Very similar story with Broadcom and some of the other chip vendors. And there are products that just launched mid this year that are still using these Gen 1 chips, brand new, even though the Gen 2 stuff's been on the market for almost a full year. So it's something to keep in mind. So when it comes to Zyxel products, everything from the NWA 110AX up to the 650, full Wi-Fi 6 features on both radios. We do have right now currently a product called the NWA 50AX, which is currently exclusive to Amazon. And we will have a product next year called an NWA 90AX, which will be available across the channel. And those products are what I'm going to call Wi-Fi 6 Lite. We're calling them Wi-Fi 6 on our website and datasheet because that's what all of our competition are doing, but they are missing some of these features that are part of the Wi-Fi 6 standard that all of our other APs do support. So I hope that makes sense. So now we'll talk a little bit here about our local area controller. I'm not going to talk much about Nebula here in today's presentation. We have dedicated Nebula webinars for those of you that are interested in our cloud management platform, which is by and far the most popular way to manage our APs these days. But I did want to talk about on-premise controller because a lot of people don't realize we still offer this. So almost all of our Zyxel products have a built-in wireless LAN controller that you can use to manage our access points. So I want to hit on some of the features here. There's nothing too exciting. I mean, it's all very similar to Nebula and to other platforms. We've got the ability for the controller to determine which APs are going to use which channels. We have a mesh-based technology, so not all APs need to have a hardwired connection. They can mesh together. We support all of the standard fast roaming protocols. One cool thing here is we have zero AP config deployment. Provided your network has DHCP, at least during the initial setup, the APs will automatically see that there's an active controller on there and will touch base with the controller. And then you can simply go into the controller and activate them, and they'll download their config from the controller. No need to configure anything on the access point itself. We have rogue AP detection and isolation. And I will warn you that you probably won't get in trouble for it, but technically people have gotten in trouble for doing rogue AP isolation. Technically, the FCC laws make it illegal to intentionally interfere with the device, even if that device is in theory somebody hacking your network or has plugged an unauthorized device onto your network. The ability to create essentially a VPN tunnel from the AP back to the controller. So that way, in this case, your controller is a firewall. You can apply your firewall rules to the network wireless traffic before that traffic then gets released onto the local area network. Dynamic VLANs, load balancing, client isolation, captive port, all the stuff you would expect in a managed wireless LAN solution. So this is just showing you here all the different models here with the built-in wireless LAN controller. You can see it's the VPN series all the way down to the VPN 50, the USG Flex series starting at the 100, and the ATP series starting at the 100. So this is showing you here the default number of APs that can be managed out of the box. And then this is the maximum number of APs that can be unlocked for management by buying a license. So if you want some other additional reviews, Network Advisor on YouTube, they have now put together a couple different comparison videos comparing our products to Ubiquiti. Go check those out. So we'll quickly go through the models here. One thing I do want to warn you is most of the 11AC models you see on today's slides are either in the process of being phased out or will be phased out at some time next year. For the most part, going forward, our key focus is on Wi-Fi 6, and we will have some new Wi-Fi 6 APs for you next year that I can't talk about today. So starting off here, this is with our flexible series. So again, these APs can all be managed directly or through the Nebula Cloud. We have the NWA 1123 ACV3. And this will be one of the models that's going to be sticking around for a long time. Fingers crossed. And the reason I'm saying fingers crossed is part of the reason why we're having to discontinue some of these Wi-Fi 6 models is because the chipset vendors are now shutting off production on these Wi-Fi 6 chipsets. They are using an older style of fabrication. So what we're seeing is a lot of these, the manufacturers of the chips are closing down the fabs to update the fabs to the newer tech. And the newer tech is being used to make Wi-Fi 6 chips, not older AC chips. We have our NWA 1123 AC HD. So it's a little bit faster version of this guy here. It has 2 Ethernet ports in it instead of just one, so you can do pass-through. And we have our NWA 11 AC Pro. This has been by far our best-selling access point for a long time. It competes very close in price to the Ubiquiti AC Pro, but you get a better warranty, free cloud management, better performance for roughly the same price. So it's been a super popular model. Right now, supply has been limited on these, but we are getting more of these in. Going up here to our Wi-Fi 6 products, when it comes to this flexible series, we have the NWA 110AX and the NWA 210AX. Primary differences between the two is more spatial streams are supported on the 5 gigahertz radio on the 210AX, and the 210AX has a 2.5 gig Ethernet connection to make sure that your Ethernet connection isn't the bottleneck for your wireless performance. So going up from here, we're going now to our Ultimate series. So the Ultimate series, again, can be managed directly, can be managed with the Nebula Cloud. They include 1 year of Nebula ProPack license bundled with them, and they can be managed by our wireless LAN controllers locally. So the entry-level guy here is our WAC 500. So it's very similar to the 1123 AC V3. One of the cool things on this is our least expensive access point that can work with our new secure Wi-Fi feature that's part of the ATP and I think the USG Flex series. Basically, that allows you to turn this access point into a cloud-managed VPN appliance that you give to employees. They plug into their existing router, so there's no worry about double natting. It's specifically designed because it's an access point to work with whatever existing router they have at home. And it gives you an SSID that basically creates a VPN tunnel back to the office for remote work. We have our NWA 5123 ACHD and the WAC 6303D-S. This is currently our least expensive smart antenna access point. And we will, it's not on the slides because it hasn't launched yet, but early in next year, we will be launching a new Wi-Fi 6 low-cost smart antenna AP, the WAC 630S, which will eventually at some point repeat this or replace this in our portfolio. For those of you doing hospitality, we have 2 custom purpose-built hospitality access points, the WAC 500H and the WAC 5302D-SV2. Primary differences between these two is this model here, the WAC 5302D-S. The S means it has smart antenna. So it can make a huge difference for you if you're putting one of these in every room. And then it also has more pass-through ports. This one has 2 pass-through ports, including 1 PoE pass-through. This has 3 pass-through ports, including 1 PoE pass-through. So you can run 1 cable to the room into your AP, and then you can run cables out from the AP to the TV, to an IP phone, to whatever other devices you may have in the room that need a wired connection. Going up from there, we have our Wi-Fi 6 products. So we have the WAC 510D, the WAC 610D, and the WAC 650S. So the WAC 5 and 6s are very similar to the previous NWA 110 and 210. In addition to controller management and ProPack bundled in, these also add the dual optimized antennas we talked about earlier. So they have the 2 sets of antennas built in that can switch between wall and ceiling mount. And then our WAC 650S, this is our flagship AP. It's our fastest access point. It has smart antenna. It has Bluetooth. It also has a 3rd radio dedicated for just scanning those DFS channels. So if at any point it needs to drop connection on one DFS channel, it knows what other DFS channels are currently available to be immediately used. You can also use that scanning radio for like rogue AP detection if you're using it with a controller. And then we've got our outdoor access points here, the WAC 6553D-E. This one, you need to buy antennas to go with it, and we will happily sell you the antennas. But that gives you the flexibility of deciding whether you want to have omnidirectional antennas or you want to source your own directional antennas for making point-to-point links. It's very common for people to use one of the radios with a directional antenna for backhaul and then omnidirectional for coverage for users. Our 6552D-S, it has smart antenna built in, but it's a directional smart antenna. So it is the easy way to make point-to-point links without needing to be that precise with how closely you've got these aimed at each other. They're also used for providing coverage to things like from outside, providing coverage inside to hospitality, or for providing coverage at like bandstands, concert venues, things like that, where you point it at different chunks of the audience to provide coverage without causing interference. And then we also have this guy here. It is an outdoor enclosure that fits most of our access points and allows you to use an indoor access point as an outdoor access point. It gives you waterproofing there from rain and things like that. And it also helps give a slight boost up to the temperature ranges that you can use that equipment in. For those of you in really cold environments, the 6553D-E has a heater built in, and it can handle operating temps down to -40. So I do want to show just a couple here comparisons real quick. I know comparisons can be kind of dry. So in this case, we're taking our 11 AC Pro. We've got a couple other models here, but let's be honest, the main guy we're competing with here is the Ubiquiti UAP AC Pro. Again, price-wise, these should be very competitive, and I do know supply is kind of limited right now on the Pros. But we're constantly getting more in. But you'll see here our output power is significantly higher output power compared to the Ubiquiti. We support more SSIDs per radio than Ubiquiti does. We offer dual optimized antenna where the Ubiquiti just has the ceiling optimized antenna, a little bit higher gain on the antennas that are built in. Full SNMP V2C and V3 support versus SNMP V1 on the Ubiquiti. Dual image firmware, which means if the firmware image gets corrupted for some reason, like during an upgrade, the old previously working firmware is kept and will automatically fall back. And of course, we offer a lifetime hardware warranty on the Pro, where Ubiquiti is just offering a 1-year warranty. And if you can hear that noise in the background, that is my dog. We had rain here 2 days ago, and her allergies are through the roof right now. Going up from here, let's talk about Wi-Fi 6. So this is our WAC 510D. Comparing it here to the Aruba 505 and to the Ingenious products. So one key thing here is Ingenious is using a pre-true Wi-Fi 6 chipset. So it is missing some features such as the upstream OFDMA, upstream MIMO, BSS coloring. We offer dual optimized antenna, neither HP Aruba or Ingenious do. We have higher output power than both the Aruba and the Ingenious product. And then, of course, we offer the free cloud management, which neither of them do. And in fact, with Ingenious, you have to buy a different model if you want cloud management versus if you don't want cloud management. So it's a pretty decent comparison there. And then lastly, we'll do here our flagship product, the WAC 650S. So this competes with the Cisco 9115, the Meraki MR45, the Aruba AP 535, and the Ruckus 750. So again, same sort of story. In general, we have higher output power than most of our competition. All of us are providing the same 4x4 Wi-Fi 6 performance here. Only us and the Meraki MR45 have that dedicated monitoring radio. Only us and Aruba offer a 5 gigabit connection for the uplink port, where you're stuck with just a 2.5 port on the Ruckus and the Cisco. So you do run into the potential that your 2.5 gig connection may be the bottleneck to your wireless users. We do offer a 1 gig pass-through port for other local area devices. And then, of course, the same stories with free cloud management, et cetera, et cetera. So that, guys, finishes up today's webinar. So again, if you have questions, send them in using the question and answer box. While I wait to see if any questions come in, none have come in yet. I do want to direct you to our YouTube channel, Zyxel America channel. There are lots of Zyxel channels from different regions and different divisions. So Zyxel America channel is the key one here for the US office for the channel. So that's where all of these webinars get recorded. So if there was a webinar you wanted to see and you missed it, you can go to our YouTube and it will be posted there within a day or two. For instance, if you'd like to go see our Wi-Fi 101 webinar or a Nebula webinar and you don't want to wait for our next live presentation, you can go watch an older version that's recorded on our YouTube channel. You can find us on LinkedIn as Zyxel US channel. And we do also have dedicated user forums, forum.zyxel.com. In addition, for a place for Zyxel resellers and users to talk with each other and help each other out. These forums are monitored by our R&D and product management teams. This is also the first place where security announcements, firmware release notes, things like that are posted. So it's a good idea to check in from time to time on the forum. And I have not gotten any questions. So either none of you can hear me or I did a better job than I thought I did explaining this stuff. So thanks for joining us. I'm going to go ahead and end today's webinar. If you did have something you wanted to say, you can email me directly, seanr@zyxel.com, or just reach out to your salesperson and they can pass the message along. Thanks for joining us, guys. Oh, I got a chat here. What was in the chat? Just a thank you. Okay. Appreciate that, Eric. Go ahead and end today's webinar. Thanks, guys.